It would extend to Jupiter's circle if you placed it where the Sun is. This massive, genuinely unsound event will explode. With more energy produced than a billion suns, these explosions rank among the universe's most powerful radio energy explosions. Are you ready for the impending events involving the massive red supergiant star Betelgeuse? One of the stars closest to Earth, it has recently undergone a notable dimming that has drawn attention and generated conflicting emotions worldwide. Cosmologists and the general public have speculated about the possible consequences of this darkening. According to some scientists, this unexpected behavior might be a sign of a cosmic explosion, which is a devastating occurrence that occurs when a star runs out of atomic fuel and collapses under its own weight, producing a tremendous blast. The general public and mainstream scientists are both concerned about such an occurrence since it raises concerns about the potential effects on our own planet. Because of its unique form and bright stars, Betelgeuse is a distinctive star cluster that is simple to identify in the night sky. It is the largest and brightest star in this constellation and is also known as Alpha Orionis. Betelgeuse saw a major mass influx in 2019, according to recent data gathered by NASA's Hubble Space Telescope and observations from other observatories. Astronomers from all over the world are interested in this behavior because it is out of the ordinary for a star of its kind. Our knowledge of stellar life cycles and the dynamics of large stars is enhanced by the remarkable event observed in Betelgeuse. Even though coronal mass ejections are frequent occurrences in our own sun, astronomers continue to disagree over how far away Betelgeuse is from Earth. Some believe it to be farther out, while others suggest it could be as close as 724 light-years. Because of their immense size and unique characteristics, red supergiant stars like Betelgeuse are difficult to accurately measure in distance. As one of the brightest stars in our night sky, Betelgeuse has a brightness that is several times higher than the Sun's. The cost of this great brilliance is high, though, as Betelgeuse accelerates the rate at which its atomic fuel burns down, hastening the end of its stellar life. The star will eventually run out of fuel and collapse dramatically under the force of its own gravity, potentially causing a cosmic explosion that might produce a black hole or even a neutron star. This begs the crucial question: is Betelgeuse a hazard to Earth if our present astrophysical conjectures turn out to be accurate? The repercussions of a cosmic explosion, occurring only a few hundred light-years from Earth, could be catastrophic. A supernova's explosion can emit an incredible amount of light, possibly as much as a whole galaxy. Therefore, the consequences of Betelgeuse's cosmic explosion could be profound and far-reaching, even though it is relatively distant, like the star Alpha Centauri. Surprisingly, humans have not yet seen a local cosmic explosion since the last one was seen in our own galaxy in 1604. But in 1987, there was a significant cosmic explosion in the Large Magellanic Cloud, which is 169,000 light-years away. That event served as a reminder of the scope and possible significance of such cosmic phenomena, even though it had enormous impacts and did not directly endanger Earth. The idea of a danger zone around a normal cosmic explosion is intriguing, and if a supernova were to happen close enough, it might have major effects on life as we know it. However, it is crucial to realize that in the wide celestial environment, gamma-ray bursts are much more powerful and present a different kind of hazard than nearby supernovae, which are very modest events. Devastating consequences can result from gamma-ray bursts, which can kill biospheres and cover planets with deadly radiation. For instance, a particular kind of cosmic explosion may destroy a planet's ozone layer, leaving it exposed to space radiation long after the blast has taken place. A recent study that described new potential hazards related to huge stars that die in such a dramatic way brought attention to this issue. Some of the brightest radiances in the universe can be reached by huge stars exploding in a supernova. A single supernova's brightness can really outshine billions of stars brought together. This begs the question of what consequences would result from such an explosion in Betelgeuse. Betelgeuse would become the second brightest object in our sky after the Sun if it were to undergo a supernova. Amazingly, even though Betelgeuse is so far away from us, it would still be visible during the day because it is brighter than a full moon. Even in the darkness, the explosion's sheer magnitude would provide a breathtaking display that would create shadows. Such a picture, which would demonstrate the unadulterated power of cosmic events, would be both breathtaking and horrifying. Even while the visible light released by a supernova is breathtaking, it only represents a small portion of the energy generated during the event. High levels of visible light can temporarily impair vision, but the high-energy radiation that is released along with the visible light is more dangerous. This radiation frequently takes the form of gamma and X-rays, which can have serious repercussions. The potential of this high-energy radiation to accelerate the ozone layer's depletion, which shields our planet from dangerous solar radiation, is one of the biggest threats it poses. Life on Earth's surface would be exposed to intense UV radiation from the sun in the absence of a strong ozone layer, which could result in mass extinction events. Over time, cosmic rays and subatomic particles moving at almost the speed of light start to invade the solar system, but the immediate aftermath of a supernova poses acute threats. The risks caused by the initial explosion can be increased by these massive beams, which have the ability to destroy ozone layers and cover the Earth's surface with dangerous radiation. Moreover, the long-term consequences of these cosmic rays may last for hundreds of years, and they carry a significant amount of the overall energy produced by the supernova. Elevated levels of iron-60, a radioactive isotope created in supernovae, have been discovered in seafloor sediments and lunar regolith, which is evidence that such occurrences may have impacted Earth in the past. This discovery raises the possibility that supernovae may have affected Earth in the previous few million years, or even more recently. Based on our understanding of the dangers posed by cosmic rays and gamma rays, astronomers have previously concluded that there are currently no close supernova candidates that provide an urgent threat to life on Earth. Ongoing studies, however, have identified fresh possible dangers connected to particular gamma-ray burst types. These gamma-ray explosions are more dangerous to planets like ours because they can emit deadly radiation over enormous distances. This is explained by the fact that a star that is nearing the end of its life is surrounded by a sizable disk of material. This disk is struck by the shock wave created by the supernova, which makes it extremely hot. High-energy X-ray radiation, which can travel great distances through space, is then produced in large quantities as a result. The ozone layer of a planet might be reduced by up to half by the most intense X-ray supernovae, which could lead to an extinction catastrophe within 150 light-years on average. Thankfully, there are no known candidate ray supernovae in the close neighborhood of Earth. The cosmic habitable zone, or the area of galaxies where conditions are favorable for life, has been better understood as a result of this research. These results imply that there might be more restrictions on this livable area. In particular, there might not be enough star formation activity in a galaxy's outer regions to generate the ingredients required for the formation of rocky planets. In the meanwhile, there are concerns associated with the inner regions, where stars originate and perish more quickly. Regular supernova explosions in these areas have the ability to irradiate the surrounding space, raising the dangers for any possible life. Our concept of where life might truly flourish has been altered by new research that suggests the inner edge of the cosmic habitable zone may be farther from the galactic center than previously believed. What will the supernova known as scarab juice look like from Earth? The biospheres on Earth will probably not be impacted, but it will be impossible to overlook the spectacle. Experts predict that scarab juice will remain brilliant for almost 90 days after it explodes, achieving a luminance that is half that of the moon, many times less than that of a full moon. In essence, it will be visible even during the day as a brilliant spot in the sky. Its dazzling brightness, which casts shadows even at night, will enthrall everyone who glances up. Since the supernova can be seen with the naked eye for months, this magnificent celestial event will surely captivate people on Earth. Although scarab juice's remnants will eventually disappear, scientists are still studying it to learn more about the life cycle of huge stars and the mechanisms that result in their terrible demise. Gaining knowledge about these enormous occurrences is essential to understanding how our galaxy evolved and how elements are created during a supernova explosion. In addition to emitting visible light, the explosion's extreme heat and pressure create a wide variety of heavy materials, including uranium, silver, and gold. In order to replenish the interstellar medium with the building blocks necessary for future star and planet formation, this process, known as nucleosynthesis, is crucial. It's interesting to note that a supernova remnant can develop into a stellar nursery, where new stars are created from the gas and dust released after the explosion. This cyclical process demonstrates how cosmic events are interrelated and how one star's demise can result in the creation of others. Long after the initial explosion, scientists have discovered a variety of supernova remnants that continue to create new stars, proving the universe's dynamic character. The function of supernovae as indicators of cosmic distance is an additional intriguing facet of their study. White dwarf star type I supernova explosions, which consistently reach their maximum brightness, are used by astronomers as standard candles to measure cosmic distances. This approach has greatly advanced our knowledge of cosmic expansion and the identification of dark energy, an enigmatic force responsible for the universe's rapid expansion. Furthermore, research on supernovae provides information about whether exoplanets could be habitable. Scientists are investigating how planets circling neighboring stars may be impacted by the radiation released during these celestial explosions, which could have an impact on the atmospheres and the possibility of life. This study emphasizes how crucial it is to comprehend the environmental factors that control life throughout the universe. There are fascinating considerations regarding how mankind may react to such cosmic events when a local supernova could be observed. Supernovae have influenced stories, folklore, and artistic creations throughout history. Not only is a star's explosion a scientific phenomena, but it also has cultural significance as a symbol of transformation, devastation, and rebirth. Bright new stars in the night sky have been seen as signals or messages from the universe in many societies. In addition, technological developments have transformed our capacity to see and investigate supernovae. These events' structure and behavior can be revealed by taking detailed pictures and spectra of them using space telescopes fitted with state-of-the-art sensors. Additionally, ground-based observatories are essential for tracking fleeting occurrences because they enable astronomers to gather data in real time and react swiftly to observations. With the development of new telescopes and technologies, such as the James Webb Space Telescope, which promise to provide extraordinary insights into the life cycles of stars and the dynamics of their tragic deaths, the future of supernova study is full with intriguing possibilities. Our knowledge of star evolution and the basic mechanisms forming our cosmos may advance as a result of these discoveries. In conclusion, research on Betelgeuse and its upcoming supernova event opens up more general conversations on universal recycling, cosmic development, and the effects of these phenomena on life and culture. By shedding light on our position within this enormous, constantly shifting universe, research into such huge stars enhances our understanding of the complex and frequently violent cycles that govern it. Supernovae, which signal the end of a star's life and the subsequent creation of new celestial structures, are also important in the greater cosmic timeline. For instance, the leftover material may develop into nebulae, which are enormous gas and dust clouds that serve as ideal environments for the birth of new stars. Complex chemistry may exist in these areas, aiding in the formation of organic molecules, the building blocks of life. Furthermore, star formation in neighboring molecular clouds might be triggered by the shock waves generated by supernova explosions. This mechanism, called triggered star formation, illustrates how cosmic occurrences are interconnected and how a single sensitive event can initiate the production of new planetary systems and stars. This demonstrates the importance of supernovae as both endpoints and catalysts for further advancements in astronomy. In the larger context of the universe, supernovae also help disperse heavy elements across the cosmos, which enriches the material used to make future planets and stars and ultimately affects the chemical diversity necessary for life. The significance of comprehending supernovae in the larger framework of astronomy and the beginnings of the materials that comprise our own planet and life itself is highlighted by this cosmic recycling.